Explaining hurdle technology in salami type sauces. This example I am discussing here is taken from the book of Leistner and Gould published in 2002. Hurdle technologies, combination treatments for food stability, safety and quality. More discussion are also available in our published book Handbook of Food Preservation, published by CRC Press, Florida. In earlier videos on hurdle technology, I have explained the basic understanding of hurdle technology and intelligent use of hurdle technology in food preservation. In the recent videos, the jam making process and cottage cheese and meat products were explained by hurdle technology and the pickle making process in the framework of hurdle technology. In this video, I am going to explain salami type fermented sauces by explaining how the hurdles are working. The purpose of this example is to dissect the hurdle preservation, considering why these hurdles are applied and how these are protecting the salami. Additionally, what are the key aspects we need to keep in mind. Please watch this video until the end and subscribe to this channel if you like the video. What are the hurdles in the case of salami type fermented sauces? In this example, I am going to explain how different stages of fermentation or ripening lead to a stable food product. There are 4 stages in the ripening process. In the initial stage, the main hurdles are salt and nitride and uniform mixing. In the stage 2, the hurdles is the reduced redox potential, that is low oxygen. In the stage 3, competitive microflora and reduced pH. In the final stage 4, low water activity is the main hurdles. I am going to provide extended explanations of each stage in the following slides. In the early or initial ripening stage, hurdles are nitride and salt, as nitride curing salt is used. In addition, uniform structure can be created by mixing thoroughly. This can inhibit many bacteria such as Pseudomonas and other gram-negative oxidative bacteria. They commonly multiply and spoil uncured meat in the presence of oxygen. In addition, structure can play a role, and then lactic acid bacteria prevail over other microflora. The microstructure of fermented sauces influences the desired ripening process as well as survival of pathogenic bacteria. Thus, microstructure is also an important hurdle. Microscopic studies reveal that the natural microflora as well as added starter cultures are not evenly distributed in the fermented sauces, but they are accumulated in small cavities, and ripening flora can be grown in small nests. Thus, metabolites first accumulate in the nest cavities and then diffuse away in the matrix of the product. Therefore, entire fermentation must be accomplished, and then we could have enough time to reach the metabolites to the distant area of the matrix in order to inactivate pathogenic bacteria. Within each nest, the bacteria, either pure or mixed cultures, are in competition of nutrients, and it impairs each other by their metabolic products. Why is lactic acid bacteria prevail? It is due to their tolerance of low redox potential, pH and water activity. As we know, redox potential is the indication of the oxygen level, that is low oxygen indicates low redox potential. pH indicates the negative log hydrogen ion concentration, that is low pH means more acidic. And water activity indicates the binding nature of water in the system, that is higher binding of water means low water activity. In addition, thorough and uniform mixing of meat and fat particles in the sauces batter are needed before casing. Starter culture could be used as liquid instead of powder. It can be added in a fashion that favors even distribution. Certainly, microstructure is an important hurdle in many food products. In this stage 2, other types of bacteria are able to multiply and oxygen can be used. Redox potential is decreased, thus enhancing redox potential hurdle. This inhibits aerobic microflora and favors the lactic acid bacteria to grow. In the stage 3, the competitive microflora, that is lactic acid bacteria, flourish by metabolizing the added sugar and causing a decrease in pH. Then we can achieve pH hurdle. This is particularly important for the microbial stability of quick ripened fermented sauces. Initially, we can observe a mixed microflora and then lactic acid bacteria compete with the pathogens and dominate the matrix. In the case of long ripened salami, nitride is depleted and lactic acid bacteria slowly die, while redox potential and pH increases again. Only water activity hurdle is strengthened with time, and then water activity hurdle is largely responsible for the stability of long ripened raw sauces. Low water activity and high pH make them more flavorful. This also illustrates that different hurdles could be used to achieve microbial stability. In addition, these hurdles can be chosen in order to achieve different features of sensory characteristics. In summary, the 4 stages in the ripening processes are: in the initial stage, the main hurdles are salt and nitride and uniform mixing. In the stage 2, the hurdles is the reduced or redox potential, that is low oxygen. In the stage 3, the competitive microflora and reduced pH. In the final stage 4, low water activity is the main hurdle. All these products presented here are developed based on experimental trials and analyzed after developing the stable products. However, fundamental understanding and a wide spectrum of prediction modeling are missing in the literature. That is, when and how multi-hurdles can be used without complete experimentation. Significant progress needs to be achieved in this regard. In the next video, I will explain what the challenges are and what we need to achieve in the future. I would like to thank you for watching this video until the end and supporting my channel.